In this lesson, for section 4.2, we are going to look at using exponent laws to help simplify expressions with integral exponents. Then in part 2, for section 4.2 videos, we will be looking at converting a power with a negative exponent to a power with a positive exponent and applying the exponent laws to solve a little bit tougher examples. First, let's do a quick little review of some terms. An integer is a whole number that can be positive or negative. When we are talking about integral exponents, we're talking about having an exponent that is an integer. Some examples of integers include -2, -1, 0, +1, +2, etc. Also goes forever to the negative side. So we have all the whole numbers that can be positive or negative. Next, we have exponent. An exponent is the number of times you multiply the base in a power by itself. A quick example would be 2 to the power of 5. The 5 is the exponent, and the 2 is the base. The whole thing is called a power. If we write the power out as a repeated multiplication, we're going to write 2 times itself 5 times. That's what the exponent means. It tells us how many 2's we're multiplying together. Last, an expression is just one side of an equation. So previously, when you were looking at polynomials, you might have 2x plus 5 as an expression. As soon as you add an equal sign and a number that the expression is equal to, now the whole thing is called an equation. We don't want an equation, we're just looking at an expression. And an expression you might see today in exponents could be 4x to the power of 2 over y to the power of 3. For our review of exponent laws, we're going to have a look at all 5 exponent laws with some examples. The first exponent law is called the product of powers law. And that's where you have a power times another power. And they have to have the same base, and they have to be multiplied together. Those are two conditions that need to be met in order to be able to simplify using this law. They will simplify by adding their exponents together and keeping the same base. So, for example, if you have 3 to the power of -2 times 3 to the power of 4, and you want to simplify those, you have to first check to see if they are two powers that have the same base, which they are. The bases in this case are 3, and they have to be multiplied together. Because those two conditions are met, we can simplify by adding the exponents. So we're going to have 3 to the power of -2 plus 4, which will give us -2 plus 4 is +2. So our simplified answer is 3 squared, and that is an equivalent expression to our original expression, but just in a simpler form. Another example that we can look at here with maybe some variables is x to the -2 times x to the -3. Again, we have two powers with the same base, and they're being multiplied together. So we keep the same base, add our exponents, so -2 plus -3. Notice how I've kept the positive or the plus and the negative separated. That is important that you keep all your signs when you're doing this simplification. Our final answer will be x to the power of, well, -2 plus -3 gives you -5. And that will be our simplified answer. The second exponent law is called the quotient of powers, and it is where you have a power divided by another power, and they have the same base. If that's the case, then you can combine them into one power by subtracting the exponents and keeping the same base. For example, if you have 6 to the power of 7 divided by 6 to the power of 10, and you want to simplify that into one power, we can do that because we have two powers that have the same base. So we'll keep the same base and we will subtract the exponents, and you will get 6 to the power of negative 3. 7 minus 10 is negative 3. Again, another example might be with a variable base. So x to the negative 2 divided by x to the negative 3. Two powers with the same base being divided, so we can subtract the exponents. Negative 2 minus negative 3. Again, keep your signs separated with brackets. Negative 2 minus negative 3 is the same as 1. So our final answer is x to the power of 1, although we don't usually write the 1, so we'll erase that and leave it as x as our simplified answer. Just a quick note as well, when you are subtracting the exponents, you always take the top exponent and then subtract the bottom one from it. So it's top minus bottom every time with this second exponent law. The third exponent law is called power of a power. In this exponent law, we have a power inside the brackets and it's raised to another power. In order to simplify this, we have to bring it so it has one exponent. Because you have a power to a power, we're going to be multiplying our exponents together, so it'll be a to the power of m times n. Some examples of this could be 5 squared to the power of 3. We have a power to a power, so we're going to times those exponents together. So if we write that out, we have 5 to the power of 2 times 3, and as a single power, 5 to the power of 6. One more example, x to the power of negative 4 to the power of 3. Power to a power, multiply our exponents together. X to the power of negative 4 times 3 gives us x to the power of negative 12. The last two exponent laws are similar. The fourth one is called the power of a product. You have two powers inside the brackets and they have different bases, and they're both raised to a power m. To simplify this, the m gets multiplied into each exponent of each power in the brackets, so you get a to the m times b to the m. An example of this might be 6x to the power of negative 2. To simplify this, we want to bring the negative 2 into the brackets into each exponent. So we would get 6 to the negative 2 times x to the negative 2. One more example might be with some different variables, x squared times y to the negative 3 in brackets, and that's to the power of 2. We still bring the 2 into the brackets, but remember we have to multiply the exponents together. So we're going to end up with x to the power of 2 times 2 times, and then y to the power of negative 3 times 2. Simplified, that gives us x to the power of 4, y to the power of negative 6. The fifth and last exponent law is the quotient, power of a quotient law. This one right here. So again, you have two different powers with different bases being divided, and they're both raised to a power of m. So the m comes into the exponents of the powers inside the brackets, and you get a to the m divided by b to the m. For an example here, we'll just do one. We could have t squared divided by 3. And that's raised to the power of negative 3. To simplify that, let's bring the negative 3 into each exponent in the brackets and multiply them. So you get t to the power of 2 times negative 3 over 3 to the power of 1 times negative 3. Remember that the 3 had an exponent of 1 because there was no number there. That will simplify to t to the power of negative 6 over 3 to the power of negative 3. That will be your simplified answer for that example. The last thing I want to talk about in part 1 of the integral exponent video is the zero exponent. And that is any number to the power of 0 is equal to 1. The only exception to that is if a is equal to 0. So this rule is only true when a does not equal 0. Just quick examples of this is, say you had 5 to the power of 0. If you type that in your calculator, it will give you 1. If you had 729 to the power of 0, it'll still equal 1. The only time that a number to the power of 0 does not equal 1 is when you have 0 to the power of 0. If you type this in your calculator, you would actually get an error or an undefined answer. It's just like dividing by 0 is not possible, it's not possible to take 0 to the power of 0. There's one more case that I want to make you aware of, and that's if you have a negative sign or negative number. In this question, we're going to have negative 4 to the power of 0, and the negative 4 is not in brackets, so the base of the exponent is actually just 4. And so we could actually rewrite this like negative 1 times 4 to the power of 0. 4 to the power of 0 will equal 1, so we'll have negative 1 times 1, and the answer to that is actually negative 1. So if your negative is not inside brackets, it's not part of the base. So you have to be careful because your answer will end up being negative.